Hello guys, welcome to my first video. Today we're going to be making an old phone charger using a battery pack from a laptop. The first step in this is to open up the battery pack with brute force. Inside you'll find 6 cells, 3 cells wired in series to make 11.1 volts nominal on the output, and a battery management system on top. Because the current battery management system is designed to output a different voltage than what we want to charge a mobile phone, we need to desolder the PCB from the battery pack. Joining the PCB onto the batteries were 4 solder joints, each of which needed to be desoldered. Then I used a multimeter to make sure the voltage output of each string was the same. These shouldn't be different because they were all in the same pack, but I wanted to make sure. I then used electrical tape to bind the 6 cells together to make it easier to solder. Make sure that when you do this, all the positive sides are grouped together and all the negative sides are grouped together. The next step was to join the 3 strings together using 1mm hookup wire. Make sure to not leave the soldering iron on any one point for too long to avoid damage to the battery pack. Once I'd done this, I tested the voltage of the whole pack to make sure it wasn't fluctuating. Also for this project I needed a female USB port. I found this PCB in the same laptop that I found the batteries in. I desoldered it using a hot air gun. Then covered the top and bottom connections with another layer of electrical tape. As I was going down, I made sure I left a gap in one end so I can solder wires to it. To control the charging of our battery pack, we'll be using a TP4056 lithium battery charger, which is capable of providing 1 amp via a micro USB port. To control the discharging, we're going to be using a step-up boost converter capable of converting 3 to 32 volts into 5 to 35 volts and delivering 4 amps of current, which is plenty to charge a phone. The next step in this process was to solder the battery wires onto the TP4056 and then hot glue it onto the top of the battery pack. I later found out the hot glue may have been a mistake because an overheating problem with the TP4056 actually melted the glue. I then cut off an appropriate length of wire, stripped the ends and soldered each end to the positive and negative terminals of the battery. Here red will always be positive and yellow will always be negative. I then soldered wires to the terminals of the boost converter and hot glued it to the side of the battery pack. Make sure in this stage of the process you leave the trimmer open so we can adjust the voltage later on. The next step was to position the toggle switch. This has to be close to the positive in terminal of the boost converter and needs to be in the way of the wire because that's the wire we're going to cut to put the switch in. The next step was to connect the boost converter to the TP4056. The negative line runs straight from the negative out terminal of the TP4056 and into the negative in terminal of the boost converter, and the positive out terminal of the TP4056 runs through the toggle switch to the positive in terminal of the boost converter. Next step was to connect up the female USB port we desoldered from the PCB earlier. This connects to the output of the boost converter and make sure to solder the negative and positive leads as shown in the video. It's definitely a good idea at this point to solder the leads onto the USB port before gluing it in place. I then made sure the charging circuit worked by putting it on charge for 15 minutes and measuring the voltage afterwards. You can also do this by measuring the charge current while it's charging. The next step is to use the trimmer on top of the boost converter to adjust it to the correct output voltage. I needed 5 volts out so I could charge a phone. After making sure this charges my phone properly, I noticed that while charging the pack, the TP4056 got incredibly hot, at times reaching 80 degrees centigrade. I resolved this issue by connecting a heatsink to the back of the PCB, which reduced the temperature to around 50 degrees centigrade, which was deemed acceptable. To finish the project off, I covered all the electronics with electrical tape to make it waterproof.